The first question, we want to change the mean to 47,000 and the standard deviation to 12,000. So it says the annual employees in a large company are approximately normally distributed with a mean of 47,000. So we changed it to that, and a standard deviation of 12,000. What percent of the people? So all of these are normal CDF function things in the calculator. So they all start with second bars, normal CDF. Question is, what do you put in there? And these three questions are great for emphasizing the three different things you could be X to do. One is you could be X to do less than. That's what letter A is about. Letter B is about a between situation. And letter C is about a greater than situation or more than. So for letter A, since it's less than 40,000, we're going to start with the smallest value we can enter into the calculator, which is negative 10 to the 99th, all the way up to 40,000, which would be the max value or the highest value that this problem is looking for. The mean is actually 47,000, and the standard deviation is 12,000. So we put that in there, and we'll get something 0.2 whatever that rounds off to 28%, because it does say what percent of people. So we have to round that off to 28%. Letter B, what percent of people earn between 45 and 65? So this time, we don't want the lowest number we could put in the calculator to start it. We want between 45,000 for the low and 65,000 for the high. And again, it's the same exact value for the mean, 47,000, and the standard deviation, which is 12,000. When you crunch that through, it's like 0.49 something, which is 50% when you round it off. And then lastly, what percent of the people earn more than 70,000? Well, that would be from 70,000 on up to the highest value, which is 70,000, 10,099. 47,000 is the mean. 12,000 is the standard deviation, and you'll come up with about 3%, 0.03. Okay. Now, number 22, you see how it says in 22, population mean annual salary for plumbers is 49,000. Random sample of 36 plumbers is drawn. What's the probability that the mean salary of the sample, you see that mean and mean, that means central limit theorem application. So we're still going to do second var's normal CDF. The lowest value it wants to know because it wants to see if it's greater than 47,850. So I put in 47,850. And then I do 10 to the 99th. Then the mean, they said here, is 49,000. And for standard deviation, because it's central limit theorem, we take the standard deviation, but we must remember to divide by the square root of the sample size, in this case, 36. So when I do that and I crunch the numbers, I get 0.8829. Okay. Number 23 talks about they do a fuel economy study, was done on two Japanese car manufacturers, Honda and Toyota. Both make excellent cars, I might add. The table below summarizes the results. Which interval establishes or represents a 95% confidence interval? Well, to do that, we're going to go, first thing we have to do is input the data, and this is talking about for Hondas, so I have to input the Honda data only. I'll do that by going to Stat, Edit, and then to List 1. I clear out whatever's in there by putting the cursor all the way in the top where it says L1, and I hit Clear, Enter. Then I go to Stat, and then I put all the values in, 38.7, 31.8, 30.0, 36.7, and so on. Then I go to Stat Test, and it's very important that you realize here that we're only entering in, I think it's 11 pieces of information. So we do not do a Z-test, we do a T-test. T-test works with limited amounts of data. So I go to Stat Test 8, which is the T-test interval test, and then I go to data or the input is data, because I'm going to use this list, and make sure you use L1, and then you choose C level, which is short for confidence level of 95%, so you make that a decimal, 0.95, and it will kick out the answer to you 30.375 and 34.77. Okay, last but not least on this particular page, a researcher is interested in a group or in the eating behavior of rats and selects a group of 35 rats out of 500 rats to be tested in a research study. So the 35 rats is a piece of the 500 rats. It is a sample of them. So it's choice A. Okay, so let's show you the next thing you can work on.